We're looking at problem 3-18. This is for MEC 275 kinematics. And this is out of the text. So I wanted to give you some guidelines and help you at least get started on this problem so you know how to piece this together and how to set it up so you can solve for it. So if you're not used to doing this type of analysis, it's hard to immediately see exactly where to start. But keep in mind that this is trigonometry based, so that should clue you in that you want to take the geometry that exists and you want to break it down into the simplest set of triangles possible. So let's first start by talking about exactly what the problem is asking for. They want to know the height of the bucket, which is at the end of the boom there, held by a pin joint. So that height is going to be relative to the ground. In other words, the base of the tires of this illustrated vehicle here. So we're looking for a vertical distance. And the first thing we want to do is decide whether or not we have any vertical dimensions that are already given to us. Now we know that the variables on this illustration have values that are assigned to them in the text on problem 3-18, and we are actually given a distance for B. So we do know the vertical distance assigned to B, and also we know the vertical distance assigned to C. Therefore, what we're actually missing or need to find would be the distance here shown in red. So let's take a look at the geometry of this mechanism and try to break it down based on the information we're given. So in the book on problem 3-18, they give you a value for A and they give you a value for C. And it should be fairly easy to see that you actually have a right triangle that forms with one side being A, one side being C. So if we have that information, we can easily find the hypotenuse or the longer side of that triangle. You should also be able to see that there is an oblique triangle that shares a side with that right triangle. So we're given a value for E and we're given a value for D. Now, if we can solve for the hypotenuse of our right triangle, that means that we have an oblique triangle where 3 sides are given. So that should clue you into the law of cosines. And you'll have to refer to the pages in your book, pages 46 and 47, as to which specific case applies to an oblique triangle where 3 sides are given. And the third triangle is another right triangle because we're given the distance of E plus F. So the only thing we know about that third triangle is one side. Now, if we can find another piece of information to define this triangle, we should be able to solve for our missing vertical component. And that number plus C plus B will give us the total height. So looking at this, we've broken down our geometry into one right triangle, one oblique triangle that overlaps onto a larger right triangle. So the key here is solving one triangle in order to find the missing information for an adjoining triangle, and then you will be able to calculate your angles so that you can find the final piece of information, which will be that vertical component that we're searching for. So use this illustration here to help guide you when you're drawing out your geometry on your engineering pad and trying to find your missing angles and or sides as you're solving this. So This, what you're looking at here, is a huge hint to help you properly set up this problem and get it solved. So when you guys come in on Monday, I want to see some answers for this. I want to see your total height of the bucket. So in other words, the height from the ground or the bottom of the tires to the pin joint connecting the bucket to the boom link there. All right, good luck.